right, so in this video, we're going to graph a couple of basic exponential functions, okay? The first one's going to be f of x equals 2 to the x, and the second one's going to be g of x equals 1/2 to the x, okay? So I've already got a table of values set up here, and I've put some values in for x. Remember, the domain here for these exponential functions is all real numbers. There's no limitation on what x can be, okay? It can be positive, it can be negative, it can be 0. You're still going to get a value out for that, okay? So it really doesn't matter what values you choose for x, but these are the 6 I've chosen to use. All right, so first thing we need to understand, if you look back up at the top of the notes, we say that the exponential functions all have a horizontal asymptote, and it's going to be at this constant out here, okay? Well, there is no constant here. It's 2 to the x plus 0. So there's an understood horizontal asymptote at y equals 0, okay? So the end behavior going to the left in this case is going to be that we're going to approach the x-axis, okay? And I'll make more sense of that as we complete this table of values. So first thing, when we plug in -2, it's 2 to the -2 power, which is 1 over 2 squared, or 1 over 4, okay? When I plug in -1, it's 2 to the -1 power, which is 1 over 2, or 0.5, okay? 2 to the 0 power, remember, anything to the 0 power is 1. Okay, 2 to the first power is 2, 2 to the second power is 4, and 2 to the third power is 8, okay? So notice, as we get more and more negative, so let's go from -2 to -3, to -4, to -5. Notice it's always going to be 1 over 2 to that power, okay? So 1 over anything can never be 0, okay? And 1 over any positive number can never be negative, okay? So this graph is going to approach y equals 0, but it's never going to get there. And it will never be negative, okay? This function can never be negative, and it can never be 0, okay? So that's why there's a horizontal asymptote at y equals 0, and that's why the graph will never cross the x-axis, okay? So let's look at that graph now. All right, so for the graph of this first function, I've gone ahead and plotted the points, okay? The function is y equals 2 to the x. We said there was a horizontal asymptote at y equals 0, okay? And we had these 6 ordered pairs that we could plot, okay? So again, this is a continuous function. There is no vertical asymptote. There's no place where we're going to have what we call a removable discontinuity or anything like that. So this function goes on forever. So going to the right, okay, it's going to go up forever, okay? And going to the left, remember we said we're going to approach that horizontal asymptote, okay? So that's the graph of the exponential function y equals 2 to the x. Now this is called exponential growth because as we move to the right, the function keeps growing and growing and growing at an exponential rate, okay? This function actually keeps doubling as x goes up by 1, okay? So that's the graph of the exponential function y equals 2 to the x. Okay, let's look at the second function here, g of x equals 1/2 to the x power. All right, I'm going to use the same domain I did before, but remember the domain for this function is all real numbers. There's never a point in time where this function is not continuous, where there's any vertical asymptote or anything that would be undefined, okay? So when we plug in -2, we're going to get, we've got a horizontal asymptote because the constant out here to the side is 0. When we plug in -2, we get 4. So it's like 1/2 to the -2 power is 2 to the second power. So that's why we get 4 there. 1/2 to the -1 power is +2. Anything to the 0 power is 1. Okay. 1/2 to the first power is obviously 1/2. 1/2 to the second power is 1/4. And 1/2 to the third power would be 1 over 2 to the third, or 1 over 8, which is 0.125. Okay. So we're going to plot these points, and that'll give us the graph of g of x equals 1/2 to the x power. Again, never going to be 0, never going to be negative. Okay, so these graphs will all be in the first and second quadrant. Okay, so let's take a look at that graph now. All right, so here's the graph of y equals 1/2 to the x power. Okay, remember we had a horizontal asymptote at y equals 1. We plotted 6 points, -2, 4, -1, 2, 0, 1, 1, 0.5, 2, 0.25, and 3, 0.125, okay? So as we go to the left over here, it's going to go up forever like that. And remember, as we come to the right now, this is going to approach that. Let's go down a little bit lower. we're going to approach that horizontal asymptote, okay? This graph will never touch 0. It will never become negative because that horizontal asymptote is there to keep it from doing that, all right? Now, as we move from left to right, this is getting smaller and smaller and smaller. This is called exponential decay, and that's going to be a huge part of what we do in the future, okay? So that's how you graph the function y equals 1/2 to the x.